Hello everyone and welcome to this video. So in this video I'm going to be comparing auth providers like Clerk and Superbase Auth. You have other auth providers, but I'm going to compare this with implementing auth yourself, and I'm actually going to show you code examples on how you could implement auth yourself, whether using a session-based authentication with Redis, or you could use JWT, JSON Web Tokens. So the thing about auth providers like Clerk is that you get authentication out of the box. So you get email verification, you get forgot and reset password. And all this functionality is very good, especially when you're just getting it right away. Also, it's very easy and fast. So it's very good for demos and MVP. In fact, I would even say you could use it in production, but it comes with a price. And that is where the trade-offs come in. So it can be expensive at scale, and implementing multi-tenancy can be tricky. So for my SaaS software, I actually wasn't able to implement multi-tenancy with Clerk, and I had to get rid of Clerk. After spending hours with Clerk, right, I found out later on that subdomain multi-tenancy doesn't work with Clerk, so I had to get rid of Clerk and implement auth from the beginning again. Also, it's an extra dependency for your application, so keep in mind that if Clerk goes down, it also means that your application goes down. But I don't think you should worry about this too much, because 99% of the time, Clerk is really reliable, and even if it does go down, it's not for long. Now I'm going to move on to implementing auth yourself. So we have login and sign up, and we'll start with sign up. So when you're signing up, basically the most important thing is that you're getting the email and password from the form, and you're going to save pass the inputs to remove every JS in it, and make sure make sure you just have a string, and then you're going to hash your password with a one-way hashing algorithm. You have Argon2 ID, Scrypt, and Bcrypt. And you also have to consider salting and timing attacks. But honestly, when you're using Argon2 ID, you don't have to deal with any of this. And even on the OSWAP website, Argon2 ID is the recommended way for hashing because it's the most resistant to brute force attacks. And then from then on, you can decide to create a session using session cookies or JWTs. When you're logging in, what happens is the email is checked to verify that it exists in the database, and the imputed password is checked to see if it matches the hash password. Remember, it's a one-way hashing algorithm, so when you get the passwords from the user, you're going to send it through the same hashing algorithm, and then later on you compare it with the hash password. Now, there are two ways in which you can validate the user's authentication state. So you can do that through session cookies, and I'm using Redis to do this. I'll use Redis in the code examples, or you could do it through JWTs. But let's start with session-based authentication. So when the user logs in on the device, so we're going to generate a session ID, and we're going to store it in our database. After we're done storing the database, we're going to send the session to the browser as a HTTP only cookie. And now this is very important, because when you're using a HTTP only cookie, it means only our server can access the cookie. So it's inaccessible to JavaScript. So that way you're preventing XSS attacks. Then we can use Redis to speed up reads in order to reduce the amount of requests to the database. So the thing about session-based authentication is that on every single request, on every single call to the server, we're going to hit the database to check if the session ID we have from the cookie is actually in the database. And we're also going to check if it's the same user that's using the session ID. So it comes with trade-offs like everything else in software engineering. So the thing about session-based authentication is more secure. It's easy to control access when the user is logged out and logged in, and you can simply revoke a user's access by deleting their session ID from the database. And I feel like it's very good in your traditional web apps, but it comes with its own calls. Like hitting a database on every recall is definitely not the most ideal thing in the world. Your database or Redis has to be queried on each request. If you're not careful when you're setting the same site attribute, a CSRF attack is definitely possible. So let's look at how the code will look like. So I'll first start with the sign up, and then we'll move into the login. When we're in sign up, what we do here is that we get the schema from the form, So you usually have like a form on your front end, and when we get it, we're going to say pass it to remove the JS, and then yeah, we destructure it, and we check if the user is already in the database. Because if they're already in the database, there's no point of them signing up. So we say we already have the email in this account, and then we generate this user ID, and then we actually hash the password that the user gives us. So this is the hashing algorithm. Remember, I said you should use argent2 ID. So if you're using Node.js, this is the library you want to use. So just import the hash and verify functions, and then you hash the password. And then when you're logging in, you use the verify password function to make sure you verify the password. So let's continue with sign up. So after we hash the password, we create a new user, insert them in our database. And hashing password is very, very important because you don't want to store the raw password in your database, because in case your database gets hacked or leaked, you don't want the hackers having the real passwords. So when they see the hash password, it's basically useless to them. After we're done signing up the user, we create the session, and then they can like continuously use our application without being logged out. I'll dive into this in a second, but let's look at login first. When we're logging in, it's very similar to signing up. We get the information from the form, we check if the user exists, and this time we actually want the user to exist in our database. If they don't exist in our database, we throw an error because we're logging in. We verify the password. So if the password is correct and it belongs to the user, we actually create a session, and that's how they're able to use our application. Now let's look at the session generation. This function is actually the function that's responsible for generating the token that we send to the browser. So it's an unsigned integer array, and then we use crypto the random values to fill in the array, and then we just encode it in base 32 form. Now, when we're creating the session, what we're doing in this entire function is we're just adding the session that we've created here into a Redis store or your database, if you like to use it that way. But like the passwords as well, you also want to hash your session ID, and then you create the expiry date for the information on Redis. And then yeah, this is the session object. So we're taking in user ID and the date we want the session to expire. Now, when we're creating the session, we're just going to check if the user exists first. If the user does not exist, we actually throw an error. After we get the database user, after we've checked the user actually exists, we actually want to store the information in Redis, but we don't want to store the password. So in this way, we just get rid of the password, and we're just using the user without password later on here. Now let's move on to this. Now we're using a promise to all, so we're running 3 concurrent operations at the same time. So the first thing we're doing is that we're actually setting the user session and their session ID, and we're setting the session, and then the EX here stands for expiry date. So we set this in Redis. We also set the user's information, user without the password. Like I said earlier, that we extract the user information without the password. We set it in Redis, and then this is actually a set. So we're just adding the user session and the hash token to a set. The reason why we do this is because sometimes the same user could log in on multiple devices. Someone could log in on their phone and log in on their laptop. They're still the same user, but the session tokens are going to be different. So that's why we do that. And then we just return the session to the browser. So let's look at how we validate the session token. So we validate the session token by actually getting the token value from the browser. If we come over here, you could see that we actually do cookies.get. So we're getting the cookie from the browser and we're passing it into this function. So when we get the cookies, remember we hashed the tokens, so we have to hash it again. This is a one-way hashing algorithm. Now we've hashed the tokens. We're going to check if the token actually exists in a Redis. And if it doesn't exist, we just return null. And then we now have to get the user's information. And we can get the user's information from Redis, right? But there's always a chance, especially the first time you're doing it, there's always the chance that the user won't be in Redis. So in that case, we query our database, and then after we query our database, we actually just set the information. We just cache the information in Redis. So next time everything happens faster. Now we get our user's data. So this block of code is just deleting entries from the database if we don't have user data. Because if we don't have user data, it means that the user is probably deleted from our database. And so we just want to make everything else consistent, and then we return null. So the user is pretty much good to go at this point. But now what we're doing is we're checking when their information, when their session is expiring. And if the session is about to expire, we just add a new, add we just add some more time. We can be 15 or 30 days to their session based on what you prefer. And then from here on, the user is pretty much good to go. Now let's look at invalidating the user session. So when we're invalidating the user session, what we need to do is we just delete all the information from already stored. So now we've validated that session. Even if they try and make the request to the session, it's not going to work. And yeah, so the last thing I'm going to look at is set session cookie and delete session cookie. Now, these two functions, they're dealing with the browser. So every other function we looked at prior to this function, they were dealing with our Redis, and they were dealing with our database. But this function actually just deals with the browser. So set session cookie, what we're doing is that we're like sending the cookie to the browser. Remember I told you that the HTTP only cookie is sent to the browser. And then we just want to set the attributes to secure, in production, and then we also want to set same site, so either lax. So we also want to set same site to lax or strict. I think lax is better because it has better UX, but it's still secure at the same time. And then when we're deleting the session cookie from the browser, we just call the function cookies.delete session name. So that's pretty much everything that you need to know when it comes to session-based authentication. So let's go back to JWTs. So JWTs, actually, the access token you're using for JWTs is not actually stored in the database. So everything is just with the server and with the browser. So how it works is that we take payloads with different parameters, name, ID, emails, and we add other headers. And now we create a secret key, and it should be only used on the server, and please use it in an environment variable. You should be the only one who knows what the secret key is. And now with the headers and with the parameters, we use an algorithm to generate a signature. Now, after we generate the signature, we're going to create a token, and this token contains the header values, contains the payload values, and it contains the signature at the end. And then we send the token to the client, and it's stored in the HTTP only cookie. So now when you're making a request to your server and we want to check whether the user is authenticated, what happens is that our token is destructured, and then the headers and payloads are used to create a new signature. Now, with our secret key and the algorithm, the new signature should actually match the signature on the token. If it matches the signature on the token, then we know that the token was made by us and the user is authenticated. And the good thing about this is that it reduces the amount of requests we make to the database, but it also introduces a problem. Nothing is stored in the database. If nothing is stored in the database, it means that if we want to remove a user if we want to revoke a user's access, it means that we actually can't do this. But there are two other ways we can solve these problems by blacklisting or refresh tokens. XSS attacks are also possible if you use local storage, so please don't use local storage. Now let's look at how we would implement this. So I'd say it's more straightforward compared to using I'd say that using JWT is definitely simpler than using session authentication. So when you're using a JWT, all you need to do is so I'm using the Jose library, and we're using the signed JWT and JWT verifier. So what we do basically is we create a signature and make a token when we run this function, and then we just send the token to the browser. And that's pretty much everything we need to do when we're logging in to create a session. And then when we're verifying the session, we just run JWT verify. So we check if the token is actually made by us with a secret key. And if it's made by us, then it's successful. So we just return everything back. We just return these values back to the browser. And if it's not successful, it wasn't made by us. So we delete the cookies from the browser. And yes, so this is everything. So this is just the basic implementation of JWT, but without like the refresh or blacklisting token. So now remember I said invalidation is a problem. So since invalidation is a problem, we can also use refresh tokens to overcome that issue. And it's quite simple, I'd say. So what we do is that we generate an access token, and then we also generate a refresh token, and then we store the refresh token in a database. But in this example, I'm using the map, but when you're like running it in production, you actually want to use a database. So we store the refresh token in our database, and then we just set the cookies. So we set the refresh cookie token and a regular access token. When we're verifying whether the user is authenticated, we check if the token has expired. If the token hasn't expired, we just do everything. Everything goes as usual. Because remember, we want the token. I might have not said this earlier, but we want the token to be short-lived, right? If the token hasn't expired, we just everything just goes on as normal. So if the access token has actually expired, there's still a chance that our refresh token is still valid. So what we're going to do is that we're going to run the refresh for function to see if the session token is valid. And if it's valid, we just generate a new token and then we authenticate the user. But let's look at the refresh token. So now in the refresh token, what happens here is that we get the refresh token from the browser, and then we try and verify it by running JWT verify. And then we also check if we have the refresh token in our database. And if it's not in a database, we return null, so the user doesn't get authenticated. And since at this point we've verified that the refresh token is valid, we just generate a new access token and send it to the browser. So that is how we use refresh tokens. Now I'll talk about blacklisting JWTs. And this is actually simpler, but I feel like the reason why I don't like this is because I feel like it defeats the point of JWT, because JWTs are meant to be stateless. But if you're using a blacklist token, then actually I won't say stateless anymore. So everything is pretty much the same when you're logging in with the blacklist method. So you log in and everything is the same. But when you're logging out, you delete the cookie and then you add the token that the user has to the blacklist. But you actually verify if the token is correct, but then you add it to the you actually verify if the token is correct. If it's correct, then you add it to the blacklist, and then you delete the token cookie from the browser. Then now this is where like the blacklist comes to action. So now when we're verifying the token, if the token is valid, what we're going to do is that we're going to check if the token is blacklisted. And if the token is not blacklisted, we can just go on with everything as usual. But if it's blacklisted, we just delete the token and return null. So the user is not authenticated. So that is pretty much everything when it comes to handling auth with both session-based authentication and JWTs. I feel like it's very good to know how to do this. And even if you decide to use Click, it's still good you know this. And you're not using Click just because you don't know how to roll out auth yourself. I feel this is very important for software engineers to know how to do.